Sixth grade lesson 6.2 is converting units of capacity. And again, we are converting units again. So good news, the same thing we were working on last time, same steps and everything are going to apply. And I hope that's good news. If it's not good news, if you're feeling like, oh, I didn't get it, well, it's still good news because you have the chance to let your brain click with it and get the fog cleared. So if you were still hazy on the last lesson, hopefully this one clicks everything into place. I will do my best to make sure that happens. All right, let's take a look at this lesson. First of all, they talk about capacity. So in the previous lesson, we did converting length, feet, inches, miles, meters, kilometers. This is about capacity, and that is the amount of a container can hold when it's filled up. So how much can fill it up is, so liquids usually we're talking about when we're talking about capacity. Gallons of milk, cups of water, pints of soda, or pints of blood, quarts, things like that are the customary units of measurement that we use for capacity. So let's talk about those conversions. Okay, so I have put on here the customary units of capacity, those conversion factors, that rate that compares different labels to each other, but it's still the same quantity, the same amount. So these were what we were using as our conversion factor in the previous lesson. And we used the ratio of what I'm converting it to over what I'm converting it from. And that made the calculation pretty easy. So the steps really were, I multiply the information I'm given by the conversion factor in the to from format. So let's take a look at this in action. A dairy cow produces about 25 quarts of milk each day. How many gallons of milk does the cow produce each day? So what I know, I'll go ahead and underline the question they've asked. How many gallons does the cow produce each day? The dairy cow, circle the information that we are given. The dairy cow produces about 25 quarts of milk each day. How many gallons is what they want to know. So I'm going to take my known information of 25 quarts, and I'm going to multiply that times my conversion factor. And my conversion factor is what I'm converting it to over what I'm converting it from. And I am converting it to gallons, so I'm going to put G for gallons there, from quarts. So I'm going to put a QTS there. And now to fill this in, I'm going to go ahead and find out what is this conversion factor here. What is gallons compared to quarts? And hopefully it's on this list. Now sometimes I will tell you it's not necessarily showing up on the list, but there's enough pieces of information where you can be the detective and get it added onto the list. So let's take a look and see if there's a gallons and a quarts. Here we go. Here's 1 gallon, and 1 gallon is 4 quarts. So that's good. It's on here. Sometimes it might say, oh, well, 1 gallon is how many cups? And I have to go, oh, well, 2 cups is a pint, and 2 pints is a quart, and 4 quarts is a gallon. And so I have to kind of adjust as I go. But in this case, luckily, 1 gallon, 4 quarts. So I'm going to put 1 for gallon and 4 for quarts as my conversion. Okay, now I will just go ahead and multiply those. I'm going to make that a fraction. I will cross reduce. There isn't really a number that goes into both 4 and 25, but my 2 labels, that should say quarts on it, my 2 labels do cancel each other out so that I know I'll end with a gallons label, which is good. That's what I wanted to find out, right? Multiply straight across. 25 times 1 is 25 gallons, and 1 times 4 is 4. And remember, the fractions are simply a division problem, so I'm going to do 25 divided by 4 to find out how many gallons that is. 6 times 4 is 24, with 1 left over. I'll do it as a decimal. 4 goes into 10 2 times. With 2 left over, throw a 0 down. 4 into 10 5 times. My answer is 6.25 gallons is how much milk the cow produces each day. That's a lot. Think about the gallons in your fridge. The cow does 6.25 gallons each day. That's a lot. All right. So same steps as you saw. This next question then goes on to ask us, well, how many pints of milk does the cow produce each day? So let's take that on to the next slide. Okay, so it continues, that unlock the problem continues as the next keyhole down there says, well, how many pints of milk does a cow produce each day? So I just brought over to this slide the conversion factor and also the question, and I just changed the question to be how many pints instead of gallons. So we still know that it's 25 quarts. We're going to go ahead and multiply the known information, 25 quarts, times this conversion factor into, what do we want to change it to, and what are we changing it from? Well, it was quarts, that's our from, and we want to change it to pints, so we're going to put pints there. Then we're going to come check the conversion factors and see which numbers go with pints and quarts when they're equal. And here we go, 2 pints is equal to 1 quart. So I need to put 2 on the pints row and 1 quart, 1 on the quarts row. So 2 pints is equal to 1 quart. Now I have my conversion factor. I'm just going to go ahead and do multiplication. Let's change that to a fraction. We'll cross reduce. The only thing that cross reduces out is the label on that case. I'll do multiply straight across. 25 times 2 is 50. Pints is the only label left, right? Right there. 1 times 1 is 1. So it is 50 pints of milk per day that is produced, which is the same as 25 quarts, and which is the same as 6 1/4 or 6.25 gallons. All the same amount, just a different way to measure them. But yeah, by now hopefully you're feeling like, okay, I think I kind of understand this. I take the known amount, I multiply it times my factor, with the label being what I'm changing it to on top and what I'm changing it from on bottom. So if you are getting to, if you're starting to see those steps play out, that is great. We'll have a chance to see a couple more like that. All right, and so here's another one, an example, this time with metric units again. We talked last time about the metric system. They use meters and kilometers for length. Well, for capacity, they use liters, and everything's based on the liters. So milliliters are a bunch of tiny little liters that build up to make a full liter. Centimeters, same thing. Kiloliter is 1,000 liters, so that'd be a lot of water or a lot of whatever we're storing. But again, they use a base 10, so that makes our calculations nice and easy. It's just a matter of moving decimals around, and it's so nice. So let's get into this one and have a look. We have a piece of Native American pottery. It has a capacity of 1.7 liters. It can hold 1.7 liters, and I should have included that in the picture. Anyways, in your book, there's a pretty picture of the pottery. What is the capacity of the pot in decaliters? What is the capacity in milliliters? Notice they're asking me 2 questions here. The capacity in decaliters and the capacity in milliliters. And the piece of information they gave us is that it can hold 1.7 liters. So I'm going to just divide my screen into 2 separate spots because I really have 2 different math problems to do, and that's probably good because you get the extra practice. Okay, so we are going to just multiply our known information times our conversion factor in a to from order. So we're going to do over here 1.7 liters times, and over here we'll do 1.7 liters times, and then I'll put our conversion factor. This first one we're going to do to decaliters. This one's the one we're doing to decaliters. That is abbreviated, I had to look it on the chart, is DAL for decaliters. Decaliters. We're changing it to decaliters from liters. That's what the information they gave us was in liters, right? So I'm going to check on my chart over here. Decaliters to liters. 1 deciliter is 10 liters. So I'm going to put a 1 on the deciliter row and a 10 on the liter row. Like that. Change this to a fraction so that I can just do the multiplication now. My my cross reduction, I'm just going to cancel out those labels, and then I will just multiply straight across because I can't right now see, maybe I can't see the reduction there. So I'm just going to go ahead and multiply across. 1 times 7 times 1 is 1.7 deciliters. And then 1 times 10 is 10, no label. Remember, this divided by this is what we're doing there. I'm doing 1.7 divided by 10. Division means that I'm moving my decimal to the left, and I'm moving it by the amount of zeros I have there. There's 1 0 there. So I would move my decimal over 1 spot to the left. So 1.7 liters is 0.17 deciliters is the answer I get there. What if they wanted me to convert it, and they did, to milliliters? Milliliters are tiny amounts, like a little sip out of a thimble of something. It's tiny, tiny amount. And we take our medicine in milliliter measurements usually because they're tiny amounts. 1.7 liters, so I take my known information, and then I take my conversion factor in a to from format. So I'm changing from 2 milliliters from liters. So let's just get those labels on there to help guide us. Milliliters from liters. Now I'll go to this scale here and see how many milliliters. Oh, right at the top. It takes 1,000 milliliters to make 1 liter. So I'm going to write those numbers down. 1,000 milliliters is what will build 1 liter. Now I can change that to a fraction. I can cross reduce, which just in this case is canceling those labels. 1.7 times 1,000. Remember, when we multiply with a base 10, we are multiply means moving the decimal to the right by however many zeros I have. That is 1, 2, 3, 0. So I'm going to take this decimal and move it to the right 3 times because of the 3 zeros in 1,000. If I don't have 3 times, I will create 3 times. And there it's going to land there. So I'm going to end up with 1,700 milliliters would be needed in order to make 1.7 liters. A little easier to calculate with the metric system. And then they give us the another way that we can use with the metric system. And I know last time you saw this, a lot of you were like, no, no, no. My brain's full. This is too much. So this you might have toned out. But this time around, when you see it, you might go, oh, I get it now. And that's kind of nice. So maybe. We'll see. So we're wanting to convert 1.7 liters into, what is that as milliliters? So what I would do is I would find liters, there they are, and milliliters on the chart, right? And that means to get from liters to milliliters, I need to go that direction. And you notice all these arrows that direction are multiplied by 10. So I would multiply by 10 3 times, which is really multiplying by 1,000, or simply moving my decimal 1, 2, 3 times over. So on the 1.7, I would move my decimal 1, 2, 3 times over to get 1,700 milliliters. So you don't even necessarily need to set up the way we've been setting up the multiplication with the conversion factor and all that. If you recognize what this is trying to do, if I go that way, my decimal goes that way 1, 2, or 3 times, depending on how far I'm going over. If I'm going this way, that's the direction my decimal moves as well. So that's kind of handy if you understand how that's used. And if you have that handy, because I know most of us don't have these memorized this way, so we'd have to flip back to page 234. Which is it? Which way does it go? So anyways, there it is again. Maybe this time it was a little more like, oh, that's not as complex as it seemed like in the last lesson. And might be a tool that you like. So works for the metric system. Doesn't work for our customary system where we're using gallons and cups and pints and quarts. So that's why they show it in the metric system part and not the other one. So good for metric system. A little easier, right? Okay. Get the practice in, see how that helps, and let me know if you need help.